Well, yeah, generative adversarial networks basically work, so they belong in the field of deep learning. And what they basically are is we have two neural networks, like ideally in the text-to-image application, we have two neural networks where the one neural network is something that generates something, like an image. And on the other hand, we have a discriminator that discriminates, is that image actually, that generated image, is that real or fake? Ideally, the discriminator wants to discriminate right, and the generator wants to fool the discriminator. In this way, while we learn on our training set, the generator and discriminator learn among each other, alongside each other. So they are getting better and better. The generator generates better. The discriminator is better in discriminating between real and fake pictures. So, and how we generate image with this is that we need to have some seed data, where the seed data is used in our generator. We generate an image, and then through the training phase, this image gets clearer and clearer until we can use that part and produce images. Well, and I think in the future, machine learning will disrupt our lives in many, many ways, especially self-driving cars. But also in the field of generative AI, we will see that many machine learning algorithms will improve because we are able to generate data, training data, to have a right, good, proper data set that is balanced, have little bias, a lot of variance, and is also enough. Nowadays, we are facing issues with lots of restricted data sets, and I think we will surpass that certain restriction to a certain extent, not entirely, because we cannot make up data as we want. It needs to be all in the realm of the possibilities, but I believe this is what we mostly will recognize: improved machine learning performances, and then basically broadcasted to all sorts of applications. Okay, so in the tech world, especially in the industry that I'm working, data science is important. So I'm working in the consultancy field, and what we see is that many companies have a lot of business processes and business solutions that they offer. And they are dealing with a lot of data, but they don't have necessarily the data science knowledge to optimize that or use these processes in an optimal way. So there is where we data scientists come into place, and we optimize the processes beyond the obvious things. So what we are trying to do is when there is a certain data set describing whatever, let's say the production line of cars, then we try to find certain patterns within that data that is beyond the observable data. So we are using machine learning algorithms that extracts the information that we need in order to optimize that process. So this is where there is a huge business potential for data science, and also the huge interest in this specific field. So going from this to other processes, such like other fields such as generative AI, we can, so as data scientists also apply machine learning algorithms in the field of other AI areas. We also use machine learning algorithms to solve certain problems. So as briefly touched upon, generating images is basically also data science, because what we do is we have a certain data set, we have maybe a text that describes an image, and that a couple of thousand entries of that data, and then we try to find the mapping with our data science methods such as generative adversarial networks, and we try to find the mapping between the features in the text and the features in the images that we produce. That's a bit mathematically expressed, but with doing machine learning, data science, what have you, algorithms on data sets, we can produce and generate these awesome applications and achieve them in the business world. So it is very important when, as a data scientist or as any company, institution that works with data and wants to create an interesting application, such as some classifier for certain objects in some video material that is publicly available or something like this. It is important that with the data material that we have, that we train our model on, that this, first, that we have enough data in order to achieve the right performance, the proper performance level. Then we need a balanced data set. We need to know, okay, this is the balanced data set of, let's say, dogs, and this is then the category of cats. We need also a data set that doesn't have too much bias, so that the representation is right. We need enough variance in order to make that algorithm, that machine learning algorithm, understand what what the baseline is and what else can also be taken into account to be prepared for some outlier applications, outlier cases. And once we have a proper data set that represents the cases that we are training on right, then we are a good set. In terms of when we want to go more into ethics, and we have, for instance, people of different ethnicities, it is very important to have these ethnicities properly represented in the data set. Not that we have more white than other people. So this is that. It's also important to include in the machine learning pipeline. It is important to know what can we allow to happen, like what mistakes can be made, so and what mistakes cannot be made. So, for instance, if we detect cancer with our application, and so it is much more costly to not identify cancer rather than to think it is cancer, but then with further research we see, okay, it's actually not cancer, it was just a misclassification. It is important to tackle and to perform certain we have to include a factor that whenever we say something is not cancer but it actually is cancer, we need to include that into our pipeline to identify, okay, that we cannot make such mistake.